All right, howdy, howdy. So this is going to be our final lecture for Chapter 14, so we'll call this Water Lecture 3. Focus here, first of all, the reading. And again, highly encourage you guys to do the reading as we go. It's pages 317 through 331. All right. And in this discussion, we'll talk about some of the water problems in the United States. We'll also talk about global water problems, which are different in many cases from the United States. And then we'll finish off with a discussion of water management and conservation. All right. So in the U.S. and Canada, first thing to understand is we have lots and lots of water. And it's not that we don't need to be smart with it. It's not that we have an overabundance. It's just that we have plenty of water. And so in the use of our water, as long as we're smart, we shouldn't have too much trouble maintaining the water we need. Now, so the other thing, though, the flip side of that is we do have water shortages in certain geographical areas. And part of that comes from the fact that certain ecosystem types, like the desert, for example, probably shouldn't have millions and millions of people in it needing water. Okay, that's beside the point. We've got Las Vegas, we've got Phoenix. Those places there, they're not going away. And so how can we manage the shortages of water that we have in those areas? All right. So one of the things we do, we use technology to take the plentiful water sources and divert some of the water from those locations to the areas that don't have the water. Most popular, and we use this with aqueducts for this process, by the way. And so we essentially channel the water through using pumps and aqueducts to different locations from where the natural stream would take them. All right. So most popular in Southern California. So Southern California, despite having somewhat amount of rainfall, somewhat frequently, they don't have a lot of surface water available to them. Despite that, we have this enormous population in Southern California. So the way they get around that is using water diversion projects from Northern California, where there's lower population. Okay, this does have some controversy attached to it. Okay, and we're going to talk about some of the problems that come from the water diversion. Some of those, of course, dealing with expenses. All right. So one example of controversy is some issues established in Mono Lake. Okay, so it's a lake, and it actually is a saltwater lake, so it's naturally salty. All right. And we'll talk a little bit about what causes lakes and rivers to become salty over time in class. I kind of want that to be an in-class discussion. But water that runs into Mono Lake, okay, brings fresh water, all right? And because of evaporation, their salt levels do build up in the lake itself, okay? Because of water diversion, though, Mono Lake itself is becoming very, very salient. So even the organisms that are adapted to the natural saltiness of the lake are no longer able to survive. And it's a really important food chain for a lot of the species that live around that area. It begins with what are called brine shrimp, which is the base of the food chain there. And the water became so salty that the brine shrimp couldn't survive, and that affected the entire food chain all the way up. All right. The court did, as a result of Endangered Species Act type legislation, reduce the amount of water that could be diverted away, and Mono Lake is returning closer, at least, to its natural levels of salinity. All right. Probably even more disconcerting, though, is the Colorado River basin itself. So the Colorado River is one of our major rivers in the United States. All right. It provides water for 27 million people. That single river basin does. So we're talking about a huge population. Along the river, there are numerous dams for hydropower. It's very similar to the Columbia River in that regard. But because we're pulling so much water out of the Colorado River, it actually, certain months of the year at least, no longer drains into the ocean. So during certain months of the year, if you try to go to the Colorado River, the mouth of it, where it's supposed to be in the ocean, you actually have a dry riverbed. All right. And this actually, the cause of this dates way back to 1922. So, there's a lot of law in place for what they call water rights, who gets to pull water and how much. All right, that goes back to that little acre feet discussion we talked about. But the 1922 allotted 7.5 million acre feet for water use. That was an overestimation of the average flow. So there's some years where maybe there's an intense snowpack in Colorado, allowing for that much water to be used without the river running dry. But the average flow of the Colorado River, 7.5 million acre feet is just too much draw out of there. And as a result, even before the water runs dry, it actually becomes so high in salt that it's unusable. Okay? And so a big project in the environmental movement right now is trying to return the draw out of the Colorado River so that it's no longer going to cause this to happen. And in fact, in class, we'll also talk about a way that you can contribute to that. So it's kind of a cool little program they have running for this. Now, another problem in the U.S. is aquifer depletion. So aquifer, if you guys will recall, is referring to water beneath the ground, and that's where we get water for wells, right? Aquifer depletion results when we're taking water out of the groundwater faster than nature recharges it. So water has to percolate through the ground, and for those deep water aquifers, it takes a long time, and it is possible to pump water out of the aquifer faster than it returns. All right, and probably the biggest concern for us is this Ogallala aquifer in the American Midwest. Okay, now keep in mind this is the breadbasket of America, agriculture city through here. Okay, so the Ogallala aquifer is actually the world's largest groundwater deposit, and the water there it's actually ancient water. It's left over from the last ice age. So as these glaciers retreated, the water that melted from those glaciers, a lot of that water percolated through the ground and fed this gigantic, enormous underground water deposit, and that's called the Ogallala aquifer. So it didn't take the farmers long to realize that this huge underground water deposit was there, and that's what kind of the whole breadbasket of America is built off of, that ability to get that water from underground during the months when Mother Nature doesn't provide us with the rain that we need. Okay? But we are depleting that aquifer in some cases at 40 times the rate of natural recharge. So obviously, that's going to create problems. If we're pulling the water out 40 times faster than it goes in, we're going to see depletion. And in some areas, it's already uneconomical, particularly in Texas. Okay, so one of our big concerns, where we grow corn and wheat and all kinds of these commodity crops, it's a big concern if we continue to deplete this resource in the way that we are. So water conservation is going to be a really, really important issue in the relatively near future. Now, so in the U.S., right, just a quick summary, we've got surface water depletion, because of water diversion, causing rivers to run dry and increasing salt content. We've also got groundwater depletion, which can, by the way, we referred to this earlier, but can cause subsidence and sinkholes. Okay. Now, when we go thinking globally water problems, it's not so much, although it is a problem, it's not so much the quantity of water and getting into places. This has a lot to do with quality of water. All right. So we have enough fresh water available to meet human needs, enough for people to drink and stay clean, and also enough for agriculture if it's used wisely. Okay? Yet, about 1.1 billion people live without access to safe drinking water. So this is a water quality issue. Okay? And things that would probably make many of these problems worse. Climate change is going to be an issue. Population growth is going to put an increased strain on need for both household use, but also for agriculture, as we need to make more food. And then when we start having water shortages, we're going to run into issues of when two countries share a single water source, who has the rights to that water? And is that going to lead to potential conflicts? Okay? So climate change, first of all, we did talk about this briefly back in previous chapters, but Really, the concern with climate change isn't so much less rain. It's more a concern of the mountains receiving less snowpack, and so that we get less water available to us in the months when we get less rain generally. So much of the American West relies heavily on the snowpack of the mountains to feed those rivers. And when there's less snow in the mountains because of warmer temperatures, there is concern that we're going to have less water available to us in those summer months. Okay. Another issue with climate change is as sea levels rise, people that rely on groundwater near the coast will have an increased frequency of saltwater intrusion that we talked about earlier. Okay. Now, drinking water problems. Again, we have about a little over 1 billion people that don't have access to safe drinking water. So it could be polluted from chemicals, but more often than not, it's diseased water. So parasites that live in the water. All right. And since our most rapid population growth is occurring in the same countries that don't have very good access to safe drinking water, obviously it's going to exacerbate those problems over time. An example of shared water source is the Rhine River. So the Rhine River travels through several of the European countries. All right. So countries upstream were discharging pollutants into the river and using the river for themselves. And countries downstream were having to clean the water for their own consumption. So is it really fair for an upstream country to pollute the river and make the next country downstream pay to clean it up? Okay. Now, this is an important kind of compare and contrast here, because here we have Western Europe, okay, and for the most part, we have stable countries, stable governments, and a willingness to cooperate amongst these countries. They kind of, we have the European Union. They view themselves as allies, okay? So, in the case of the Rhine River Basin, the countries did cooperate to clean up the water, and they all benefited from that Rhine River agreement, or Rhine River Treaty, I think is what it's called. So when we compare that to other countries where maybe we don't have the political stability, these agreements are a little harder to come by. And one case is the RLC. So the RLC is in what's called the former Soviet Union. So now the Soviet Union has split up. There are countries that share this one body of water. So it's an inland sea. It's salt water. There are fish, thriving ecosystems. So if we look at the RLC in 1967, so there's rivers that feed the RLC, right, and keep the water level at a certain height, okay? And so if you look in this area right here, right, see all this green? That is because of irrigation, so it's agriculture, all right? So rely heavily on agriculture from the streams that feed into the RLC. All right. Now, as the agriculture became more and more widely used, they're drawing more and more water out of those rivers that feed the RLC. We can see that level of that sea decreased drastically over this 30-year period between 1967 and 1997. Now, all the salt that was already in the sea remains in the sea, right? And so as the water level slowly decreases due to evaporation, and less water being fed into the sea, the salinity of the sea increased, and we saw fish populations and native populations decrease dramatically. Now, along the RLC, many people relied on the fishing industry for their livelihood. Okay? But again, because the former Soviet Union that's now split up, they couldn't come to good agreements on how to manage the issues of the RLC. So Mono Lake, like I mentioned back in California, is going back to its normal levels. That ecosystem is reestablishing itself. The Rhine River Basin, because those countries could cooperate and come up with a treaty, they were able to get that water cleaned up and be better for it. Here's what's happened to the RLC since 1997. Boom. Just dropped a bomb on you guys there. Holy cow. Look at that. That's an entire inland sea that is more or less dried up. That is craziness. And again, it's because they lack the political stability to truly tackle this problem. So now, not only is our sea dried up, I mean, we're talking about an entire ecosystem that is essentially vanished. It's nuts. Okay, now let's extend this discussion to other parts of the world. The Jordan River. I don't know how well you guys know your geography. The Jordan River is the river that is shared by countries like Israel and Palestine and neighboring countries. Now, if you pay any attention whatsoever to global issues, you would know that that is not a politically stable region. So when this body of water is used by a country like Israel, and maybe they use more than their fair share of the Jordan River, how are those neighboring countries going to feel about that? And what sort of conflict is that going to lead to in parts of the world like that? The Nile River is another example. It travels through many, many African countries, and as you guys hopefully know, because you have half a clue, African countries do struggle with political stability. So how do they go about solving those water problems in places where people just can't get along? Creates some issues. And so, much like wars have already been fought over oil today, there's a pretty good chance that in the future wars will be fought over water. All right. Now, looking forward, if we go globally today, or as of 1995, we can look at percentage in the U.S., for example, of water that's withdrawn as a percentage of the total available water. If we extend out to 2025, we're expected to nearly double our water usage in the U.S., putting us in a state of water shortages. Okay, it's just kind of a little graphic there. So, water management. How do we tackle our water issues? So the main goal of water management is to provide a sustainable supply of high quality water. So basically use water in such a way that nature can recharge it for us at the same rate, and then making sure that water remains high quality in the sense that it can be used for industrial and agricultural purposes, but also that it's safe for humans to consume without disease or fear of lead poisoning or things like that. Okay, so dams and reservoirs are going to be an important part of water management. Water diversion is going to remain an important part of water management. New issue is this idea of desalinization. Okay, and we'll talk about that in more detail in just a second. And then also using wastewater and recycling that water. So those are a couple of things we'll talk about here next. So desalinization, or desalination sometimes. That is, we have these oceans full of water, way more water than we would ever be concerned about using up. Okay, the trouble is it's about 3.5% salt, and that's too salty for us to use for drinking, too salty for us to use for cleaning, and absolutely too salty for us to use for agriculture and irrigation. So can we take the salt out of the water and then use that water for those purposes? So there's two methods we can do that. One of them is distillation. So essentially you evaporate the water, you heat the water up, the salt stays behind, you recondense that water, and you have fresh water that comes out the other side. And the other, more commonly used, is what they call reverse osmosis, which is forcing the water through what's called a semi-permeable membrane, which allows the water to go through the membrane, but keeps the salt behind. Okay, so this is something that's being explored to greater and greater degrees. Trouble is it's expensive and it's energy intensive. So if we're going to rely more and more on desalinization, we need to come across a way to, first of all, finance it, but also make up that added energy. Okay, now if we're going to use desalinization, it's probably going to be tackled for household water use. It's just really not practical on the agricultural scale. We just can't get the salt out of the water fast enough to irrigate, the millions and millions of acres of agricultural land. But we can use it for drinking water, particularly, and it's already an important drinking water source in the Arabian Peninsula. About 70% of the water in Saudi Arabia for drinking comes from desalinization, and also in parts of North Africa becoming more and more widely used. Okay, so how can we meet the water needs of a growing population And probably the most important place to look for ways to conserve is our number one water user, and that's, of course, agriculture. So we talked earlier about flood irrigation, just how inefficient that process is. Okay, and then we talked about overhead irrigation, which is much more efficient, and lots of these areas have gone over to that use. And even more efficient is what they call micro irrigation or drip irrigation, sometimes called trickle irrigation, in which case the water is fed through tubes and it's allowed to just drip and deliver water rather than to an entire area. It delivers it just to the plant's roots. So we're not watering soil that's not being used. And we lose essentially zero of that water to evaporation because it's delivered, rather than spraying it or flooding it, it's delivered through enclosed tubes. Okay. Part of the trouble with this, though, is it's expensive. So who's going to help pay for that? All right. In industry, we can conserve water through recycling. So lots of industrial processes don't need high quality water. They just need water for cooling. Okay. In which case, we can take water that's maybe been polluted during an industrial process and reuse that water. Rather than sending it out to nature and just consuming more and more of our high quality fresh water, we can recycle water, and there's a huge potential there to save water. And then, of course, around your house, we've already talked a little bit about this. One of the things we didn't talk about is this gray water. So gray water is water that goes down your bathtub or your sink. Okay, so again, not water that comes from the drain of your toilet. They call that black water. Gray water is water that probably has been used for a shower or down your sink or down your washing machine. And what you can do is reuse that gray water, not for drinking. You can reuse it for flushing your toilet. Okay, so do we really need water that you can drink going into your toilet to flush your poop down? No, we can use water from your sink, right, that you wouldn't want to drink anymore, but you can use that to flush your toilet. Okay, you can also use a lot of that water, provided that you don't use too harsh chemicals in your cleaning processes, to water your lawn. You don't have to water your lawn with drinkable water. You can water your lawn with water that maybe has some detergent in it. It's mostly fresh water, and your lawn's going to be just fine. Okay, you can install water-saving household fixtures, so your faucets and shower heads can be low flow. You can install toilets that use less water. You can use high-efficiency washing machines. All these things have that potential to conserve household water. And these are things that are, installing a gray water tank is probably an expensive endeavor, probably best used for new construction, low-flow fixtures, high-efficiency washers, and toilets. Those things are extremely cost-effective and easy to implement. All right, this presentation is getting pretty long-winded, so I'm going to cut us off there. We will talk more about why water in inland seas becomes salty in the first place as it relates to our lab tomorrow. All right, keep after it.